So the radius of convergence is found when we take a limit as n goes to infinity of the next term, the n plus 1 term, and the current term, the nth term. Okay, because that says we're going to compare the next term to the current term, and if that ratio is always going to be less than 1, then we can say it converges, and greater than 0. If it's greater, then we know it's going to diverge. So this is the limit we need to compute. So that means we need to know what the series looks like so we can make a Maclaurin series. The quickest way, though, would be to use a table of known Maclaurin series, to either remember this table or to be able to have it nearby. So this kind of looks like this one, right? But it's not the same. So it's math. We're saying that this function is equal to the Maclaurin series when summed from n equals 0 to infinity. So we can take a derivative of both sides, and then hopefully we can get something that looks more like this to the 4th power. This is 1 minus x all to the negative 1st power. So if you take a derivative, it's going to be negative 1 minus x to the negative 1st times the negative 1 because of the chain rule. So that's just, sorry, to the negative 2nd because we took a derivative. Went down by 1. So that's, when you simplify that, that's 1 over 1 minus x squared. We need something over 1 minus, we need 1 over 1 minus x to the 4th. So let's take the next derivative. So the negative 2 would come down, and then it would be times another negative 1 again. Okay, because this was negative times negative makes it positive. So it's going to be positive every time because of the negative we get from the chain rule. Then we take one more derivative. Then we've got something that's pretty close to what we were looking for. 6 over 1 minus x to the 4th, all to the 4th, like this. And we said that's equal to the sum of n equals 0. Oops, this whole time I should have been taking a derivative of this side. Taking a derivative of both sides and setting them equal to. So the derivative of the left side should equal to the derivative of the right side. And since n is a constant, that's n times x to the n minus 1. This term here, when we take a derivative. It's still a sum from n equals 0 to infinity. If you take another derivative, the n minus 1 comes down, then the power gets reduced by another one. And if you take one more derivative, okay, and then if we divide that 6 from both sides, then we say that 1 over 1 minus x to the 4th equals n minus 1, n minus 2, all over 6 times x to the n minus 3. It's a sum from n equals 0 to infinity. So now we have something that matches up here. Except instead of x, we're going to put 6x to the 4th. So our Maclaurin series is the sum from n equals 0 to infinity, n times n minus 1 times n minus 2 over 6, and then instead of x, we're replacing it with 6x to the 4th. This is all to the n minus 3 power. So we got our Maclaurin series. So now we need to take the n plus 1 term. So everywhere where I see an n, I'm going to put n plus 1. And this is 6x to the 4th. N plus 1 minus 3, that's now n minus 2. And then we're going to divide that by the nth term. So that's n minus 1, n minus 2 over 6 times 6x to the 4th. That's n minus 3. Okay, so you would flip and multiply. That's going to make these cross cancel. This and this are going to cancel. This and this are going to cancel. So we get n plus 1, 6x to the 4th, all to the n minus 2. This is divided by n minus 2, 6x to the 4th, n minus 3. And then to simplify algebraically just a little bit more, these are the same bases. So the numerator is subtracted by the denominator. That's going to be n plus 1 over n minus 2, and then n minus 2 subtracted by n minus 3. So that's going to be 6x to the fourth to the first power. Subtract, just double checking my math. That'll be plus a 3. Yeah, this divided by this makes this. Okay, remember for the ratio of convergence, we're finding the limit of this ratio as n approaches infinity of the absolute value of these. So n plus 1 over n minus 2, that's going to 1 as we approach infinity, because plus 1 minus 2, if you do that to infinity, it's negligible, right? Infinity plus 1 divided by infinity minus 2 is just the same thing. Same two quantities divide by each other. And then we've got 6x to the fourth here. Still an absolute value. So that means that this would be, since we're looking for the ratio of convergence, that means the absolute value needs to be between -1 and +1. Otherwise, it's not going to converge, right? So that's why we had to add this inequality. This has to be between -1 and +1. So if you divide both sides by 6, and then raise both sides to the 1/4 power, then we're going to get -1 over 6 to the 1/4 power. That's less than x, which is less than the same thing except positive. So that's the ratio of convergence. 1 over 6 to the 1/4. But Newton wrote it like this. These are equivalent. 6 to the 3/4 divided by 6. Oh, wait, no, those aren't equivalent. Right, because 3/4 subtracted by 1 would make negative. I got a negative 1/4. I got a positive 1/4. Oh, no, that is equivalent. I'm sorry, because this is 1/6, so that's 6 to the negative first. So this is what Newton wrote. What I wrote is equivalent, just in a different way. So I think it would accept either answer.